Okay, so moving to the lecture number 11, normalization. So before understanding the normalization term, let's move to the question that is very important, which is functional dependency. So question is, what is functional dependency? So as the name suggests, functional dependency is the dependency between the attributes. Okay, so let's suppose there is x and there is y, and with the help of x you can determine y. So this is a functional dependency. This is nothing but a functional dependency. For an example, there is a roll number. There is a roll number, and you all know roll number are primary key and roll number are unique. So with the help of roll number you can determine student. You can determine student. So this is a functional dependency. Okay, so xy, the left hand side of FD functional dependency is known as determinant, and the right hand side of the production is known as dependent. So determinant and dependent. Got the point? Okay. So now next is type of FD. FD means functional dependency. So basically it is of two types, trivial and non-trivial. Trivial means, let's suppose with the help of A we can determine B. So here A with the help of A we can determine B has trivial functional dependency if B is a subset of A. If B is a subset of A, let's suppose there is a, then B lies over here. So we can say it is a trivial functional dependency, because you are saying here that B is dependent on A because it is a subset of it. Got the point? And non-trivial means not a subset, not a subset, but still it is dependent on A. It is still dependent on A. So this is the thing. Now rule of FD, functional dependency. So there are three rules which is very simple. Number one is reflexive, augmentation, and third is transitivity. So number is reflexive. If A is a set of attributes and B is a subset of A, then A gives B holds. If A is a subset of B, then A gives B. A gives B. If A is a set of attributes and B is a subset of A, then A gives B. So it is true. It is true. A can gives B. So this is our reflexive. This is very simple. Reflexive is the very simple. A can give B, or A can determine B. Got the point? So now next is augmentation. Augmentation means if B can determine A, for an example, B can determine A, then adding an attribute to the functional dependency won't change anything. Let's suppose there is it's right like this. Then if we add some other attribute like X and there also write X, then there is no change, and X is our attributes, another attribute. Okay, so there will be no change. So this is our augmentation, or our second point. Now transitivity. If A gives B, if A gives B and B gives C, so it means A also can gives B. A gives B, B gives C, then A can also give C. So this is our third topic, third point. Now question is, why normalization and what is normalization? So let's talk about normalization. Uh, normalization. So there is normalization. Normalization is used to minimize the redundancy from a relation. So you are saying there is a dependency, so we have to remove this dependency to make our DB more easier, become more clear. Okay, so in order to make it simple and to remove this redundancy, to remove this dependency, we use normalization. So normalization is used to minimize the redundancy from a relation. It also used to eliminate undesirable characteristics like insertion, updation, deletion, anomalies. Okay, so I will teach you about anomalies, but before this you have to understand the normalization term. Okay, so normalization is used to reduce redundancy from the database. Okay, so why normalization? To avoid redundancy in the DB, not to store redundant data. So there are redundant duplicate data. In order to remove this, we have to use something that is called normalization. What happen if we have redundant data? So your question is, what if we have not reduced the redundant data? Then insertion, deletion, updation become very hard. And this is our anomalies problem. Anomalies means problems. So there are three to four kind of problems that arise. One is insertion problem. If we have a duplicate data, then insertion is very difficult, deletion is very difficult, updation is very difficult. Okay, and if there is a redundant data, then DB size will also increase. Okay, DB performance become very slow. These are the problems that arise. So normalization solve these problems. Normalization is, in the other term we can say, it is a decomposition. Decomposition means breaking. We will break the table in such a way that redundancy will remove, or redundancy will minimize, you can say, because it is very difficult to remove 100% of redundancy. So type of normal forms, normalization is the, I will as I said, normalization is nothing but decompositions of table. Okay, so we will decompose our table. Let's suppose there is a table number 1. I will explain you types of normal forms. There are 3 to 4 types, mainly 4 types are of our normalization. So number 1 in normal form is 1f. 1f normal form. No, 1f means one normal form. It's the first normal form, you can say. So let's suppose there is our table. You are seeing here, this is our table. So what you are observing, that this is our id, id1, id2, name, let's suppose ab, phone number, let's suppose there is some phone numbers. Now in our second tuple, you are saying there are multi-valued attribute. So if there is a multi-valued attribute, we have to convert it into one nf, means we have to single valued attributes. So what we have did here, in our one nf, we are doing our 99 into the second tuple. Okay, rest of the thing is same. This is our conversion of our table into a one nf, because there is an anomaly which is multi-valued attribute. So one nf says, if there is if there is multi-valued attributes, you have to convert it into a single valued attributes. Okay, relation must not have multi-valued attributes. This is a one nf. Now 2nf. Now what is 2nf? So what is 2nf says, relation must be 1nf. If you are converting into 2nf, it should be, it is must that our table should be in, our relation should be in 1nf. 1nf, it is mandatory. There should not be any partial dependency. All non-prime attributes must be fully dependent on primary key. Non-prime attribute cannot depend on the other primary key. So it says all non-prime attributes. Prime attributes means of this prime attributes are there. Yeah, this they are uniquely identify the table or attribute, other attributes. They are our prime attributes, and all other are non-prime attributes. So it's saying non-prime attributes must be fully dependent on primary key. All the non-prime attributes, these are all are dependent on our prime attribute. Okay, so let's see. So there is a table. Let's say let's see, is there any existing any problem or anomaly. So you will see here, student id, project name, and student name. Okay, Ramshyam is our student name. Project name are AB. Project ID is P01, P02. Student ID is 12. So here project ID, and project ID and project name. So we can say project ID can determine project name. So we can say our project name dependent on project ID, but project ID is not our primary key. So there is a problem. There is a problem. What is the problem? Our non-prime attribute dependent on another non-prime attributes, and we have to solve this problem. So what we can do? We can decompose or break our table in such a way that we can convert it into 2NF, or we can reduce this problem. This is non-prime attribute depend on another non-prime attribute. Okay, so let's look into it. So what we have did, 1 p01 and round. So 1 2 3, we have included this in a single table called student table, and there is project id, project table. In project table there is a primary key, which is here a foreign key. Okay, so make a relation between them. Okay, so we have made in such a way that project name is on the project table, and student name on the student table. So the redundancy become, so we have reduced the redundancy. Okay, or we will finish the redundancy, or not redundancy, we can say our non-prime attribute depend on another non-prime attribute. We have reduced this kind of thing. So this is it. You can say, you can see there is no dependent on anything. Okay, all are dependent on primary key. This is also dependent on primary key. This is also dependent on primary key. So with the help of this we can easily do this. Now the third thing is 3NF. 3NF. What 3NF say? It is very very simple, and we don't need any examples to explain you because it's very simple. 3NF. So no transitivity dependency exists. No transitivity dependency exists. There should not be anything like A determine B and B determine C, so that A determines C. This is our transitivity. So if there exists any this kind of things, then we have to reduce this. Okay, so this is very simple. No need to explain more about it. Okay, so it is this. Now BCNF, voice code normal form. You can say it 4NF, but BCNF is also is a different kind of things. Okay, so BCNF, it is also important. 1NF, 2NF, 3NF, 4NF, and BCNF. These four are very important. Okay, so BCNF. What BCNF says? Relation must be in 3NF. First condition is 3NF, and what 3NF says? It also be it must be in second 2NF. So BCNF, there is a functional dependency. A gives B. A must be a super key. A must be a super key. If there is this kind of thing, then A should be A must be a super key. One point is this: you may not be clear about. You might be not clear about clear this topic, clear this term by this line, because it's complicated. But when you read this line, you will get more clarity. We must not derive prime attributes from any prime or non-prime attributes. We must not derive prime attributes from any prime or non-prime attributes. Our prime attributes. What is prime attributes? Let's suppose there is ID, student ID, and there are some project name, and something like that is student ID, not single-handedly a prime attribute. Both combinedly called a primary key. Both combinedly called a primary key. So in order to make a primary key, we have to use both the attributes. Okay, so this is our primary key. Student ID plus project name is our primary key. For an example, so student ID and project name, both are called prime attributes. Both are called prime attributes. So we must not derive any prime attribute from any prime or non-prime attributes. Now I will explain you with the help of this example. Okay, so look at that. Look at here. Student ID. There is a student ID. There is a student ID. Student ID 01, and there is also a student ID because there are subjects like Java, C, Python, Java, and professors PJ, PC, PJ2, PP, PC3. Okay. Now, what BCNF says? What BCNF says, and when we have to apply our BCNF? So you will see here student ID. There are 001, 101, 101, and there are Java, C, Java, Python, Java, and there is project PJ professor, PC professor, PJ2 professor, PP processor, professor, PJ3 professor. So what is it? So primary key. What is primary key? With the help of our student ID and subject, with the help of this we can determine professor. Okay, single-handedly we do not, with the help of student ID only we cannot determine the professor. You will see 001 101, very sorry, 101 cannot determine professor. In similar way, 101 102 cannot determine professor, because if you are observing here 101 and 101, it is possible that 101 student can take more than one subject, like 101 takes Java as well as C++, or you can say C. Okay, so there are different professors PJ and PC. Okay, so what you will understand, like with the help of both the attributes we can determine professor. So in the similar fashion you will see professor can determine subject, and this is the problem. PJ always teach you Java, PC always teach you C, PJ2 always teach you Java, PP means Python professor always teach you Python, PJ3 always teach you Java. So this is the problem, because non-prime attributes determining the prime attributes, and this is the problem. We have to convert into in such a way that this kind of things remove. Okay, this kind of problem remove. So BCNF conversion, the student ID, and we are taking project professor ID 1 2 3 4. Now professor ID and student ID we have mentioned here. Now you will see here I also make another table, professor ID. This is a foreign key, this is our primary key. Okay, so foreign key become its primary key. So 1 2 3 4 this kind of things are there, our primary key is there. Now professor and subject, professor pj pc p3 this kind of things are, and java and subjects are there. So you will see now subjects cannot determine the professor, because and our professor cannot determine PID. So now we have removed this anomaly. Now we can say now our table is converted, our relationship is converted into BCNF. Okay, so I hope you got the clarity of BCNF. Now advantages of normalization. Normalization help to minimize data redundancy, create our overall database organization, data consistency is maintained in DB.